Hello. Can someone confirm if I'm audible?
Yes, audible.
Okay. Okay. So let's just wait for one more minute and then we will start today's lecture. So before we start, I just want to know what was covered till last class when we last met. Uh,
After neural networks,
okay. 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 So today we will see CNN then. So the tutorial was also done on neural network, right?
yes, sir.
Okay. So today we will see CNN. Okay, so let's start. It's already 8:10 now, 6:10 now. Please let me know when my screen is visible. Mm, Is my screen visible?
Yes,
Okay, it's visible. I think let me just set up this thing. I want to delete all these. You can ask. Hmm. Hmm, let it connect. So today we will see convolutional neural network, and we will see through tutorial notebook. We will discuss what does it mean, and I think today mostly we will be done with if we look at this tutorial and discuss the CNN. I think we will be done for today. Next class we will see the other topic then. Okay, so what is convolutional neural network? You do convolution though, and we will look at each of these. So these are some of the libraries that we will be importing. I think now most of you must be familiar with NumPy. Matplot library is used for plotting images and other things. So we will use that for plotting. And Torch, how many of you are aware of Torch library? I think in neural network tutorial, if you have done, you must have seen Torch library being used there, right? In the first place, is my screen also visible? Should I increase the
yes,
size? The size is okay, or you're not able to see the screen, see the code? The size okay? Should I increase the size? Is this better?
yes, sir. Size okay.
Okay. So you must have seen Torch library too, right? When you did neural networks, right? This is the first time you are seeing Torch library.
Yes, sir.
First time or what is yes for first time or not the first time?
So first time I hear this.
Okay, ठीक है. So we will see use Torch to construct all our neural network thing that we will do. You must have heard about optimizers. When you read neural network, you must have read about stochastic gradient descent, like gradient descent algorithm. You recall doing that? Hello.
Yes, sir. Optimizer.
Yeah, you did recall that you did stochastic gradient descent thing to optimize your neural network parameters, right? No, yes, because we will not be going into we will not be doing it now through functions, we will just use those as libraries. So, uh, so you have done a stochastic gradient descent when you did neural network, right? Okay, so let's look each of these. So today we will, our main focus today is to understand what CNN model is. How is it different from neural network? And to understand those, we will not look into the details of stochastic gradient descent. We will just use the library to call that function and optimize our parameters. But what we will focus on, how do we construct these CNN models and what are these CNN models? Okay, so let's import all the necessary libraries. It's taking time. Let it import everything. While it is importing, let's look into some of the important concepts. So we have this image though. So I say image is a 5 by 5 image. So it's like, oh, 5 cross 5. So there are like 1, 2, 3, 4, 5. So it's a 5 by 5 image. So you can see this is a 5 by 5. This image that you see 101010 is called image. The white color bar here is the image. And the zero that you see here is called zero padding. So the padding size is currently 1. So it is zero padding the image. And why do you do such thing? We'll see this thing very clearly now. So when you do the kernel size of 3 by 3, it means that you constructed a 3 by 3 matrix which has value 0, -1, 0, -1, 5, -1, 0, -1, and 0. And you take this kernel and then you convolve around the image. How many of you know what convolution means? Have you studied the matrix convolution thing? Yes, no, no, yes. Many of you have studied. Uh, Okay, so I'm assuming that people have not studied what convolution is. So what it does is that you put the first look at this. You put this matrix and convolve with this 3 by 3 range. So in the first case, it will convolve with the first value, and you multiply 0 with 0, 0, 0, 0, -1 into 0, 0, 0 into 0, 0, -1 into 0, 0, 5 into 1, 5, and you add multiply and add. So 5 and -1 into 1, -1. So 5 minus 1, 4, 0 into 0, 0, -1 into 0, 0, 0 into 1, 0. So its first value becomes 4. And similarly, if you move this matrix, the kernel, slowly one at a step, you multiply each value with the corresponding value and add this value. That gives you that particular point. Okay. So if you take this image, this part of the image, convolve with this kernel, it will give you this particular value. You move with one. That's called stride size. That your stride size is one. That you're just moving one step at a time. So you are just moving one step at a time, and that give you the entire output matrix. Okay. So if you don't pad, you simply actually start from this size 1, 2, and 3. It will become a 3 cross 3 matrix. So currently, even if you have a kernel size of 3 cross 3, and if you don't do padding, it will create a construction of 3 cross 3 matrix. Can everyone see that if you don't do padding, it will create a matrix size of 3 cross 3 instead of 1, 2, 3, 4, 5, 5 cross 5. If you do padding, it construct and do a convolution with 3 cross 3 kernel, it created an output matrix of 5 cross 5. But if you don't do padding, and if you just apply kernel of 3 cross 3 kernel on the true image, which is a 5 cross 5 image, it constructed an image of 3 cross 3. It will construct an image of 3 cross 3. Can everyone see this thing, or they are not able to see this?
Yes, sir. See.
Okay, so for those who are not able to see, look at this. If the kernel size is 3 cross 3, so the image is only the white region, right? So it will actually only convolve this region. You'll get one value. Stride is 1. So you move next step, and this is the second value that you will get. The third value you will get from this image. So in a row, there are only three. There are three columns then: one, two, and three. So how many rows will be there? So there are three columns, and the rows will be one row, the next row will be this, and the third row will be this. So it's a 3 cross 3 matrix that you will get. If you don't do padding, you end up actually getting a smaller size image rather than a bigger same image. So by padding, you're able to construct same size image. So it is a 5 cross 5 image with padding, and without padding, the image size will also reduce correspondingly. So these are the three things that you must know. So stride, kernel size, and padding. So padding is just zero padding. Kernel size is what is the kernel that you will be multiplying the entire image with. Stride is at what length? The stride is currently one, so you are moving with one step at a time. If the stride is two, you will be moving two steps at a time, right? Okay. So what does input channel means? So how many? So in a image, a colored image, if you represent in if your computer has to read that color image, it actually reads numbers there, and it creates three channel: the red channel, blue channel, and the green channel, RGB. So that's why it is called RGB image. That's a color image. So every channel. So if an image is there, what is the component of redness in that image? What is the component of greenness in that image? And what is the component of blueness in that image? And that's how RGB comes. And each channel contains the intensity of uh, each of these points. So if you consider this, this is a black and white image, right? So there is either 0 or 1. So that's how this 0 1 is constructed here. So you see this is a black and white image. So the 0 1. So there is only one channel in it. A black and white image only has one channel because it has just 0 or 1. So there is no color there. It's only either there is black color or there is no color. So every pixel will have either 1 or 0, either black color or no color. But in an image, colored image, you will have three channels: a red channel, a green channel, and a blue channel. And each pixel will have how much degree of redness does this pixel have, how much degree of blueness this pixel have, and how much the degree of greenness that each pixel will have. So there will be three channels. So not just one, there will be three such matrices. So that's how it will become. The input channel will become three, and the output channel can also become multiple. So if you have one kernel, so it is going to multiply that kernel with one. So if you can make two kernels here, so you will have two such outputs, right? If you have one kernel, which is a 3 by 3 matrix, let's say we will construct another kernel of 3 by 3. So there are now two kernels 3 by 3, and we will multiply the first kernel with this matrix. We get this output of 5 by 5. The second kernel, where we multiply with this matrix, this zero padded image, we will get the another output, and this will make the output channel to be 2. So that's how the output channel will become 2. If you have two kernel, the output channel will become 2. If you have three kernels, what will be the output output channel size? If you have three such kernel, like three such 3 by 3 matrix, what will be the output channel size?
So three.
Yeah, 3, right? Because the one kernel will produce one channel output, second kernel will produce the second channel output, and third kernel will end up producing a third channel output. So the output channel will become 3. And you will see that sometimes we will actually create multiple such channels to produce different outputs. Okay, so let's unpack further though. So this function is exactly doing the convolution. This is zero padding and one stride. So image and kernel will pass and will do one stride. So I will leave the code to you, but it is doing exactly what this is doing. So it's moving one step at a time and constructing this image. Now our goal is not to do. You can look into this algorithm though. I will share this algorithm, but we will look into how this algorithm works though. Let's see. So say we have this image. You can see this is a grayscale image, like 0 or 1 image. There is not no 0 or 1, not 0 and 1. It's not binary. It is 0 to 255. So each image, the degree of is there. So how much black color degree that you want? 0 means completely white, and 255 means black, I think. So these are the values. So in this region, it's completely nothing is there. I think 0 is black. Okay, so 0 is black and 255 is white. Okay, so let's see. So this is a grayscale image, and we want to blur the kernel. Okay, so you can see what blurring. I think I want to delete this. Clear output. How do I do all the clear output heads? Hmm. Is there a way to clear all the outputs? Run or interrupt, change session, manage, insert. Okay. I can't find show or hide output. Control Shift M. It doesn't do anything. Okay, anyways. Okay, so what is this blur kernel does is that now we have a 5 cross 5 image. So this is a 5 cross. Okay, so what we do is the kernel size is 5 cross 5. Let's see. So we have this image, SRI image is there, right? So if you look at this image, this is a very big matrix though. Let's print this matrix, how this matrix looks like. So it's okay. So it is a show data. So this is how the matrix will look like. So you have so many 255. Okay, so 255 means white. So all these numbers that you see 255, 255, and it's a matrix of size 530 cross 500. So it's such a big matrix. And if you look at these data in an image form, it is actually this. So 255 is white. All these values are white. So this size is 500 and this size is 530. Okay. So this size is the number of rows are 530 and number of columns are 500. So this is just a simple search. Let me just try see if I can print some numbers till say 30. So you can see that all the first 30 values, the first 30 values are all white, and first say 80 values. Oh, so okay, the first 80 values are still white though. Mm, let's see if I say 120 to 250. So there are some different numbers now. There is some 221, 520, 251. So there are some different degree of red whiteness are there. So the image is represented in the current form is a grayscale image, which simply says the degree of whiteness. 0 means complete black and 255 means white. So it is just a number between 0 to 255. Now, a blur kernel, what we are trying to do is that the kernel size is all 1, 5 cross 5 by 5 divided by 25. So there are so every value is 1 1 1. So a kernel is 1 1 1 1 1 all 1 1 of a size 5 by 5 matrix. And since it's a 5 by 5 matrix and we want to normalize it, so look at this. So there are 25 numbers that we have kept. I just want to normalize each of these numbers so that we do not increase the intensity of any of these numbers. Okay. So if you do that, and if we convolve this blur kernel with this, and this is how it create a blur image. So this is a clear image, and if you convolve with this image, what it does is that it ended up actually blurring the image. So you are just taking an average of all the points that you see. So at each of these points, you're taking simply an average. So it is 1 into 0, 1 into 0, and divided by 25. So average value of this size, you will keep here. Average value of whatever the value here is, you will add this. So if you take all this average, slow moving average, it blurs the image, right? Can everyone see this? It's blurring the image.
Yes, sir.
Okay, so let's do something more. What about if we actually make a matrix of size 1 by 1? What will it do? Okay, so let's say size is uh, size is say 1. So let's write this thing, size by size, size comma size. So since want to do average, so you need to multiply by the total number of points that are there. So there are, so it's size of a matrix is n cross n. So the total number of points that there will be is like n into n square, right? So you need to divide by to create an average value. So if you create a 1 cross 1 kernel, and if you convolve with it, will it blur the image? What will it do? How will the output look like if we do a 1 cross 1 convolving here? How will the image look like? Okay, so uh, let's look at this image. So if you have a 1 cross 1 kernel, that means that you have just a single value here, and you want to convolve each of these points with just single point here, 1 point. What it does is, so 1 into 0 0, 1 into 0 0. So you just move one kernel everywhere, one size kernel everywhere, one stride at a time. The output will look like what? If you have just a single one kernel, one by one kernel, and if you multiply all these values, the output, how will the output look like?
Zero padding.
Exactly, it will look like the image itself, right? The zero padded image exactly is like zero padded image, right? Like if you just have one here, multiply with 0 0 1, 1 into 0 0. So all these first column will become 0. The first second column, 1 into 0 0, 1 into 1 1, 1 into 1 1, 1 into 1 1. So all these values, the second row will also be copied exactly the same. The output will also have the same second row. Third row will also become the same third row of output. Fourth will also become the same fourth. Fifth, sixth, seventh, fifth, sixth, everything will become, and seventh will become exactly the same copy, right? The output will become exactly equal to the input image. If you have one kernel size of 1 with value 1, can everyone see this?
Yes, sir.
Okay, so let's look at this. How let's do this thing then. So we have this size. Why? What is the issue here? Could not broadcast. I see. I see. The size 1 is too small. I think the code is not written in a proper way, that it's not broadcasting correctly. Okay, it is not able to broadcast. I think the code is not properly written such that there is an error though. But if you do that thing, it will still be able to do the same thing. So currently we are doing the same 3 by 3 kernel image, and we are blurring every point. So you can see that it is blurring the values. So if you increase the kernel size, you will see the blur effect to increase though. So currently the size 3 blur looks like this. Let's look at size 7 blur. So you can see that the blur, it became even more blurred, right?
Yes, sir.
So if you increase the blur, so increase the size, you will increase the blur effect. So you can see that it has become now, it is even more blurred. So what it means is that why it is becoming more blurred is because now you are taking 13 by 13 image, 13 by 13 kernel, and taking an average value of each of these. So if you have a matrix kept here 13 by 13, it will take the average value and then replace that point with that average value. So the bigger the kernel size, the blur, it will create even more blurry image. Okay. So if you have a 3 by 3 image, it still looks sharp, but it is blurred than the original. Okay, so this is what this blur kernel is. There is another kernel that is there. It's called edge detection kernel. So what it does is that you take every point, you replace, you subtract every corner point with the middle point. So you have these 8 different points here. So it's a 3 by 3 kernel. So you have 9 different points, and you subtract all the sides with the middle point intensity. So you multiply 8 times the middle point and subtract all the side points there. So you're just keeping the middle point there and subtracting everything around it. So Can you see the value what it is doing? It's subtracting all the sides and keeping only the middle point as a subtraction. So whatever the middle point is there, that they will keep it, and everything else they will subtract it. And it creates an image that is sharper and just the edges are there. Okay. So what about if we increase the intensity of this middle point? So make it, let's just make it 20. Can you see it has now increased the intensity and now subtracting every corner. So you're just keeping only the edges of the image. Mostly edges are surviving. Everything else is now almost lost. So if you increase the intensity further, you can see that nothing will survive. So mostly it will become white, as because 255 is white color, right? So the more the intensity of these middle points becomes, the mostly it will end up actually just keeping only the part of the edge, and everything else it will be at 0. So but if you decrease the intensity, like make it 1, then it's like gone. Everything is you're subtracting everything. It's all becoming negative now. So the convolve is that the more negative becomes, it actually clips to 0 though. So that's why you're not able to see anything. So anything less than 8, let's just keep it 5. It's also negative. It's mostly black, you will see. But you can see that it is only able to detect edges now. So basically you're subtracting the surrounding points and keeping the intensity of the point higher. So anything below 8 is make it negative, because there are 8 points that you are subtracting. So you should at least give the 8 point, the center point higher, to make sure that the edges are properly detected. If you increase the intensity too high, the edges will still be visible. It's just that it will make it more white towards side, because 255 is white and 0 is black. Is this okay? So we are still doing the convolution. I just wanted to let you understand that what does each kernel does though. Each kernel has a different effect on the image though. So we have this blur image. We are able to create this blur image. We are also able to detect edges now. Now we will try to sharpen the image. Like we will increase the intensity, sharpness of the image. Rather than subtracting all the sides, we will just subtract the top value, the bottom and up and down and left and right value, and zero out the sides, the corners. We'll just care about what is the top value, bottom value, left and right. And look that we are actually increasing the intensity of the middle value. To ensure that it becomes more, the intensity of the middle point increases. And you can see that it has become slightly sharper. If you keep it like 4, there will be more black points there, because now you are subtracting the 4 points with 4. So all the 4 points will be lost there. Okay.
Okay, sir.
Okay. So now we will actually look into the convolutional neural network. So the kernel is simply constructing a different image. When you multiply with a kernel on an image, it constructs different kinds of images though. It can be blur image. It can have different effects though. So our goal in CNN, what we do is that these kernels that are there, we try to learn these kernels. What would be the value of these kernels that will be there, such that we are able to classify certain images. Say you want to given an image of a cat, you want to tell the computer should identify whether it is a cat, dog, mouse, elephant. What is this animal? So what convolutional neural network does is that it learns this kernel matrix that you see this matrix. It learns this kernel matrix such that it constructs this output, a different form of output. And from this output, it hopes that it will actually translate the neural network, or the model will be able to learn from this output. It will be able to predict what is the image though. It is a cat, mouse, dog. What is it? Okay. So let's look into this. So this is the core idea. So we will first download the dataset, the train dataset from CIFAR 10 dataset. CIFAR 10 dataset is the 10 class dataset. There is only 10 classes in this dataset. So we'll download these dataset. So all these 10 classes are plane, car, bird, cat, deer, dog, frog, horses, ship, and truck. So these are the 10 classes that are there. And we will train with this dataset and test our algorithm on the test dataset. So we are creating a batch size of 16. So we will be working with a batch size of 16. We will shuffle all the data set and number of workers are 2. Okay. So the important thing is the batch size is 16 and we are shuffling all the entire data set. So let's create our data loader. So you see that this data loader is nothing but it just creates this X and Y. And you'll see. So if you look at the size, if you okay, so what it does is that you actually ended up we call this iterator and next. It will sample X, which is of a batch size 16, and you see that the image is a colored image. So it's a 32 cross 32 image. So first is R 32 cross 32 image of a red channel, blue RG. It's a green channel and a blue channel. So three channels are there. 16 images are there and 32 cross 32 matrices are there. And y, the corresponding value of y is 16. So it means that each 16 image, each image has one of these 10 categories. So that is why it is 16. So let's plot these images. So let's plot. We are plotting only 8 images here. It's figure size. Okay, we are only plotting 5 images here. And enumerate x. So it's 5 images that we will be plotting. So x is the first image that we will sample. Permute, why do we need this permute? Is because we need to put the channel at the back. So the first it should be in a form of 32 cross 32 cross 3. That's how a matplotlib we can read. So that's why we are putting. Okay, let me show you what it means. So if I take x of I, x of 0, sorry, x of 0, it predicts this large tensor value. And the shape, if you look at the shape, it is 32 cross. Now if you permute this, dot shape, you are basically saying that I will just move this 32 cross 32 in the front and 3 at the back. That's it. This is what you are trying to do.
Okay, sir.
Okay. So we are not changing anything. It's just that the matplotlib IM show only works with in this form if the image is in the form of 32 cross 32 cross 3. There is nothing else that we are trying to do. But if you look at all the images, so there is a deer image. It's difficult because we have made it to 32 cross 32. It is actually breaking. But assume that this is you can see it's a deer there. It's a plane, it's a frog, it's a cat, and it's a cat and it's a frog. The images are very not so clean, but if you reduce the image size, yeah, you can see that if the image becomes slightly more smaller. So the point is, the reason it is not so clean is because there are only 32 pixels here. So it will be even more small. It's a very tiny image, but we are increasing the size of the image. It's like if you have very small image and if you expand that image, it breaks, right? So that's why it is breaking. It's actually a very small image and we are trying to plot it in a very big image of size 8 cross 30, 8 cross 2. So if you reduce this size to 1 and say 3, so you can see it has become slightly sharper, right?
Yes,
So the
sir.
image is very small. That's why you feel like, oh, it's like, why is it so bad? It's not bad. It's that the image is too small. It says of size 32 cross 32. So 32 pixel in x-axis and 32 pixel in y-axis. So it's a very small image. And you can see to get such clean image, the image size should be, you can see it was 530 cross 500. So many pixels, like 500 pixel in y-axis in the column and 530 in rows. So it's a very big image though. That's why you are able to see such clean, sharp image. But if you plot this 32 cross 32, it's very small, very tiny part of this image. It should be, if you make plot small size, it will become very sharp. But this is the image though. So this is X and the corresponding Y. So dear photo image and the label is dear. Plane and the plane. Our goal is to train our convolutional neural network CNN model to learn to identify, classify these images. Okay, so let's try doing it. So what we construct first is that we are going to construct our kernel store. Okay, so in this is our model. We first take our model. So the input channel is 3 because it's a RGB image. So there are 3 channels, right? You remember this 3 channel, 32 cross 32 cross 3. So this is 3 channels are there. So the input channel is 3. We are going to construct 7 kernel channels. Okay, so let's understand what does input channel mean. So here the input channel is 1 because there is only one image. But if there are 3 images, so the kernel size will become 3 cross 3 into 3, right? It should have 3 inside. There should be 3 images, 3 of this kernel size too. So then only it can convolve with all the 3 values, right? And for each kernel multiplication, you will create only one channel. So if the kernel, there are 7 kernels, it will create 7 channel output. Remember that when I asked that if there are 3 kernels, what would be the output channel? So there will be 3 output channels. So if there are 7 kernels, there will be 7 output channels in the output. And if the image is 3 channel input, so the in channel is 3. Where did it go? So the input channel is 3. The output channel is 7. That means you are constructing 7 kernels and the kernel size is 5. So you are creating a 5 cross 5 kernel size. There will be 7 such kernels and the input channel is 3 because there are 3 in images. There is RGB 3 channel. Okay, the first input channel. The max pool, what it does is that it's also a kernel. So it's also a kernel of size 2 cross 2, but it does something interesting. So let's go to this part. So if you apply a max pool thing, so it does is that it takes this value, if say max pool of size say 3 cross 3. So in this area, in this matrix, it does not multiply. What it does is that what is the maximum value in this 3 cross 3 image? And in this case, it is 1, so it will put 1 value. Then it will move one straight and then again ask the question, what is the maximum value in this image? It will say 1. So after applying, so let's go back. So this max pool is a very simple kernel that just does maximum value. So you first apply this channel, it creates an output channel of 7, and then you apply a max pool channel of a size 2 cross 2. Now for the second layer, it just becomes a 7 channels are there and just outputting max 2. For the third convolution layer, now the input channel becomes 7 because you created 7 kernels of it and then therefore the input channel became 7. Now you want to create such 15 such kernels of size 3 cross 3. Okay, so now you have created even more channels now. And a kernel of size 3. So if there are, if you want to create a 15 channel output, a kernel size of 3 will be required plus 15 such kernels will be required to create this 15 output channel. Again, you apply a max pooling layer. Now, what you do is that you create a multiple input channel. Okay, so where is this 540 coming? It's just that the okay, I will see. So you have this linear network. So it takes an input of 540 size and it creates an output of 200. Then again, the next linear layer, it takes, this is a neural network, simple fully connected neural network, linear that is written. It takes an input of 200 and creates an output of 50. Similarly, it takes an input of 50 and creates an output of 10. So 10 is the number of classes. Okay. So now look at this. First you apply convolutional neural network, conv1. Then you apply a ReLU function, activation function. And then you apply the max2. So max pooling layer. Similarly, you take the same X, apply third convolution neural network, it will create an output channel of 15. You apply your activation function and then you apply your max pooling convolution. Now, what you do is that now it's actually a matrix, right? or everything is a matrix of size of number of channel as 15. So with the size of X is, so here after your max pooling, you will create an image of 18 cross 18. So you will create an image of 18 cross 18 of 15 such channels. So if the image is 18 cross 18, no, you will not create 18 cross. You will create 6 cross 6 image. You will create a 6 cross 6 image of 15 such channel. Okay, so it's a 6 cross 6 image, and the output channel is 15. So you have 15 such channel, and therefore you have 540 number of points. So that's where this 540 comes in. Okay, so you flatten that entire matrix into just a single vector, a long vector. If you see, this image is also like multiple such points. So now you create such a long vector, and then you apply your linear layer. So like your neural network or fully connected neural network. So you pass your X and create your output of size 200. You pass another input layer. You create a size of 50. You pass your another layer of size, and you create a size of 10. So your final X is of size 10. And if we print this, we will see this thing. If we print our model, this is how our model looks. You have this convolution layer, you have a max pool layer, convolutional layer, max pool, linear, linear, linear. And this is how you have constructed. Okay. So this is how our CNN model looks like. Till this point, any doubt? So we are constructing multiple such kernels. So we have this 5 cross 5 kernel of 7 such kernels. You have 3 cross 3 kernel of 15 such kernels. And then we are expanding all the kernel. Like we are this matrix, we are just flattening this matrix into a vector, and then simply apply our fully connected neural network. During your neural network class, you must have learned about fully connected neural network, and then we simply apply those fully connected neural network on this image, on this flattened vector, and the final output is 10. So we are just getting one of those 10 outputs. Okay, is this okay?
Sir, okay, sir, but that 540, how?
Oh, 540. But generally, what you do, how do we calculate this? It's slightly more complicated though. So if you look at this, it's not, this is very complicated. If the image, when you were given this image is a 5 by 5 image, and you, after padding, it became a 7 by 7 image, right? And when you apply this 3 by 3 kernel, you can estimate that, okay, so if you, there is 3 image, so if you slightly move in 7, there will be only 5 output that will be remaining, because it can only move in one side. So how do I tell you? So it's like 7 minus 3 plus 1. So you look at this, the 3, 1, 2, 3, 4, and this 5, fifth. You can't go anything beyond. So it's like you can estimate a 5 by 5 image. So for every kernel, you can estimate what will be the output of the image. And similarly, from this output image, if you apply a 3 by 3 kernel on it, so what will be the output for if you apply a 3 by 3 kernel on the output image here? If you apply a 3 by 3 output image, so 5 minus 3 plus 1, right? So let me the output. So you have this 5 by 5 image, 1, 2, and 3. So you can see that if you apply a 3 by 3 kernel on this 5 by 5 image, you will get a 3 cross 3 image, right? So similarly, you can estimate the what is the final output of the image into the channel number. Okay, so let me do it here. In this case, after this max 4, or after this max pooling 4, you will create a 6 by 6 image, and there will be 15 such kernel. So if you apply all these things regularly, like the kernel size 5 by 5 kernel, it will you do there is no padding here. So the say 32 cross 32 and the kernel size 5, it will reduce the image size, and it will construct some image. Similarly, if you have after you do max pooling, it will also reduce the size because you are reducing 2 by 2 images there. So it will reduce the size of the image again. And on this reduced size, you apply 3 by 3 kernel again. 3 by 3 kernel. It will further reduce the size. So and again you will apply a max pool. It further reduces the size. So the size of the total image, if you actually want to sit and calculate, you can estimate what is the total image size, or there is a way to actually calculate. I forgot the way, but there is a way directly to calculate what is the kernel size at this point. Once you know the kernel size here, you can once you know the image size here, and kernel size is already known that you have kept 15 such kernel. Here it is the image size is 6 cross 6, and then there is 15 such kernels. So total number of points in that image in that big matrix is like 6 into 6 into 15. So 540 such points are there. So you flatten that matrix into vectors, and then you start applying your neural network, fully connected neural network. Okay. So till this point, you have to calculate how many points are there in that big matrix. Once you know that number of points, it's just that the input to that first neural network would be first neural network, fully connected neural network would be that many number of points. Okay.
Okay, sir.
Okay. So we will be using cross entropy loss, and we will be using this. Iitm is just an advanced version of stochastic gradient descent. We will use that, and we will train. So we will enumerate over the entire data loader. So we will take the input and the label. We will put both the input into GPU. So we are currently using GPUs, and optimize. So optimizer, it takes that it will first set the cross entropy loss to 0 grad. All the gradients will be removed. You will estimate the output from this input. You will estimate the output and estimate the loss. So our loss matrix that we have chosen, this is cross entropy loss, and then we will back propagate. We will take the gradient, and we will optimize our algorithm. Like we will take the gradient, we will do alpha times the gradient thing, negative direction of the movement, to reduce the loss, and we will estimate the running loss. Okay, let's print R. So let's wait. It is still running. So it was going through all the data points. The first loss came as 2.055 in the first run. There will be 10 such runs that we will be going through. Okay, let's just wait. It will take only 2 minutes. So you can see that the loss is decreasing, right? It should decrease, right? Because you want to minimize the error. two more epoch, and we'll see the results. Okay. So observe that the loss is continuing to decrease. At every point, it is decreasing. Even though sometimes it is slowly, but it is still decreasing. So we can continue running for more number of epoch. And when I share this tutorial notebook with you, you can try running for longer epoch and observe that the loss will continue to decrease. And at a point, it will not decrease any further. It will start slightly increasing, decreasing. It will not change much. During that point, you can stop and test your accuracy on the test data set. So we will now test the accuracy on the test data set, that how many of the label that it was able to correctly predict. And let's just wait. It was only able to predict with 40% accuracy. It tested on 10,000 data points. This was never trained on those 10,000 images. It was only able to get with 40% accuracy. 60% of the time it got wrong, but still better. So there are 10 such classes and you are able to get 40% accuracy with just such a simple model, like two kernels, and that's it. There is nothing much there. So the loss is still decreasing. So if you actually continue training for slightly longer, you may find that the loss on the test data may also improve. The accuracy on test data may also improve. Okay, now let's visualize what is happening at each of these kernels. So remember that I said that we have constructed a kernel size of 7, the another kernel size of 15. Let's look at each of these kernels. What are they learning though? What are these output images learning? Remember this thing that we did? That if you applied this kernel on this image, it made this image sharper. If when you apply this kernel, edge detection kernel on this image, it gives you the edges. So what have these model learned though? Let's look at what have each of these points have learned. So let's look at these values. So you took this image, the bird image, and when you applied your first kernel, this is what they have learned though. It took this image, made it more closer to the image. So this is what it is learning. Each of these points, this is what each of these images look like. So there are 7 such kernels, remember? 1, 2, 3, 4, 5, 6, 7. So 7 such output channel will be there. So you took this image and applied that kernel and you get this image. When you applied this max pooling, so it took this part and 2 cross 2 and it just found the maximum value. It made it entirely black. So this became entirely black, but it was not able to do anything. But in this case, it became an edge. You can see that there is this sharp edges that it was able to detect. Certain places, something is learning something else. It may be learning how the neck looks like, the side of the feather. See, each point is detecting each kernel is trying to detect something else though. Remember now we have this 15 kernels now. So each of these, so look at this, there are 15 such kernels. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, and 15. So you have such 15 such kernels, and each of these kernels are learning different values. Okay, note that we are increasing the size of these images. These images are very small. So the 32 cross 32 may be slightly smaller than this, and the final image size is 6 cross 6, right? So it will be even more smaller though. So since we are increasing the size, we are seeing such blurry images. But if you look at if we had a bigger image and did all these processing, you'd be able to see that some of these images are learning edges, sides, corners, and once based on this, we are able to assign which value is high. So you can see that this is bird image. It is assigning bird as high, and it is also assigning ship. It thinks it is very close to ship though. I don't know why it thinks it's close to ship, but these high level features, these feature level things that we see here, is trying to learn different values from here. So if we rerun this on different image, let's run it on horse. So it thinks it's a close to deer though. It does slightly look like a deer, but it thinks that with high probability it's more looks like a deer. So this is how convolutional neural network trains these features, and each of these blocks actually have some meaning. So what is this kernel learning? Each of these kernels are learning to learn different features now. Okay. Any question on this? Hello. Not, then let me first share this notebook. I think uh, yeah, I think I have downloaded. No, no, I think this would be better. I've updated this download notebook. Okay. So I will, I think today, I think I should not start anything new because I will not be able to finish today. So let's stop till this point. We will take questions now. If you have a doubt regarding CNN tutorial, and I will share this thing first. Let me share this notebook first. Oh, I see. Hmm. Okay. I just shared you the notebook and the image that you will need. Can you just verify that you can see those notebook and uh, images that are there in the zip file?
Yes,
Uh,
sir.
or you're able to see both the image and the notebook, right?
Yes, sir.
Okay. So to use that image, so this is how you should use. So I will just show you once again. So once you load your system, once you upload your notebook on the Colab system, what you should do is that you should take. How do I oh, okay. Okay. So what you should do is that you should take your image. So this is the image, and directly drop here. Since I have already dropped that image, it is already there, and you can do different kinds of convolution. You can try with different filters though. I tried with these things. You can try with what happens if you construct some very interesting different numbers and see what happens if you do convolution with those kind of images. You can construct such different images, play around and see how these convolutions are learning. But the main idea of convolutional neural network is that you learn these kernels though. You learn different such kernel, you construct the output matrix, and finally you take this output matrix and make this matrix into a vector form. And then use this vector to output the values that whether it we use for classification or any other downstream task that you want to. This is the whole idea of convolutional neural networks. Okay. This ends the convolutional neural network part and the tutorial. So, any doubt? I think there will be some Kaggle projects too, so that you have to complete. So you may want to utilize all these information that you have learned, all these tutorial notebooks that we have shared. You may want to use those to solve those Kaggle problems. Uh, at least, is the intuition clear behind CNN convolutional neural network? If you're not able to, even though if you're some of you are not able to fully understand what is happening behind the scene, but at least the intuition is clear, right? Okay, so I think if you look at these notebooks, practice yourself. If you have any doubt, please message us. You can message in the WhatsApp group and we will try to respond to those questions too. If not, we will take those questions in the next class. If you feel we should take the question in the next class, we will take those questions in the next class. But yeah, so we will be ending today's lecture because I don't want to start anything new now because we don't have much time. It's only 10-15 minutes is remaining. Any question, any doubt that you want to ask? If not, then we can end today's lecture. So those who have doubt, they can stay and ask. If not, then they can drop too. I will be here for another 5-10 minutes. I'm not going to start any new topic today because it will take a lot of time to start a new topic. I think it's better fair that we start tomorrow. That's it from my side. Questions, else you can drop. So there is nothing that.
So I have a doubt on kernel, sir.
Okay, please ask. Should I share my screen so that you can ask it better?
Yes, sir.
Okay, let me share the screen. So what doubt is there? Yes.
Sir, on starting kernel size is 3, the output also they giving the 3. Is kernel and output are equal?
Oh, no, 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 no. Our kernel and output is not equal. You see, the image input is not 3. The image input is of size 7 cross 7. After padding, count the number of image though. There is 1, 2, 3, 4, 5, 6, 7. The number of rows is 7 and the column is also 7. 1, 2, 3, 5, 6, 7. So it's a 7 cross 7 image now. It's a 7 cross 7 matrix, and when you multiply with a 3 cross 3 matrix, it is giving an output of a 5 cross 5 matrix. Can you see?
Yes, sir.
It is not the kernel size. The output size is not equal to kernel size. It's a different size, right? When you actually multiply and move in 7 cross 7 kernel, if you multiply with a kernel of 3 cross 3, it will construct a matrix of size 5 cross 5. That's what it is. It's not the same.
Okay, sir.
Any other doubt? Others can drop though. There is nothing. They don't have to stay longer. Since I will be here because I will just see if some students wants to ask question. If you don't have any questions, you guys are free to drop. Okay. If there is no further question, then we can end today's lecture then. Or if there are any other person who wants to ask anything.
So one thing, sir.
Yes.
Sir, use of optimizer.
Use of optimizer where in CNN.
Yes, sir.
Okay. So if you look at the optimizer that we use was an Atom optimizer, right? It's a very common optimizer that has become a default optimizer that everyone uses now. It's just the advanced version of stochastic gradient descent. So you have this SGD algorithm that takes the gradient of the batch and directly does alpha times the gradient value. Atom, it still does the same thing, but with a very nice form. And it just directly don't apply. It does modification of this gradient, that how big the gradient should be, how small the gradient should be, and it just applies the same learning rate. So alpha times the gradient, it will move in the gradient direction, but the intensity, how big the gradient should be, it just changes that gradient value. Okay. So it's the same thing, it's a slightly advanced version of SGD. And there is nothing you can try with SGD too. I'm sure there will be SGD is also there. So you can apply SGD. So let's apply SGD. SGD is the same stochastic gradient descent that probably you have learned in the last class. So if you apply SGD, it is same SGD, but I think it will be it will have more. It will not have a such nice loss function. It will take time to converge. So SGD is slightly now no longer people don't use SGD as a default. They generally prefer Adams now. Atoms have nice properties that it was once you are very close to the once you are very close to the optimal point, it will not diverge, it will keep moving very slowly. If you are far, it will move fast. When you are very close to the optimal point, it will start moving slowly. So you can see if you apply SGD, you will see different optimizing curve. But it is the idea and the intuition is very similar to SGD. There is nothing much difference. So in general, when you are using any algorithm and you are writing any neural network, people directly use Adam. They don't generally use SGD. It has become such a default values now that people now trust Adam is a very better optimizer compared to other. Okay, but we can see that the loss function is still reducing, and it's nice. The SGD is also able to reduce the loss function better. I will see how much it reduces to. I feel like SGD is doing really well though. In fifth epoch, it has reduced, and it is continuously trying to reduce the value. Maybe the test accuracy might be better if we use SGD. Uh, who knows? Let's see. So even at the seventh epoch, the loss is still decreasing. 3 more epochs. Okay, so it has reduced the loss to 1.469. Let's see what is the test accuracy now. Last time it was 40%. Let's see
Yes,
what
sir.
is that. Oh, it is 42%. It has increased 2% accuracy now.
Yes,
It's
sir.
nice, right? So in this case, it seems like SGD might perform better. But in general, Adam has become the default thing. In this setting, probably SGD has performed better. But in general, SGD may not be so directly better. So what we use a sophisticated version of SGD is called Adam, and there are many other though. I will not say the only Adam is there. There are many other algorithms that have come, optimizers have come, but Adam has now become a default that everyone just directly uses Adam. But yeah, in this setting, Probably SGD is better. Any other doubt? Is this okay?
Yes, okay,
Uh,
sir.
okay. So it's nice thing. So you can also play with the notebook that I have shared. Try doing all these things and see if you can improve these